Welcome back to Van-Gelder Tutoring. Today we're going to be looking at the mole part 1, where we're going to cover what a mole is, as well as covering some of the basic calculations you're probably going to have to do during your A-levels. Now, I will say before we get started that the mole is, generally speaking, one of the trickier topics that people do tend to struggle getting their heads around. If you are struggling with this topic, you are absolutely not alone. At the same time, it is also absolutely integral to studying chemistry at A level. Throughout first year and second year, a lot of the content that you're going to cover will be based around this particular topic. So do make sure you fully understand the mole before you move on and try to go on to another topic which may also involve molar calculations. So, age-old question, something that you've probably been asked by friends in school or colleagues, or something that you will probably have heard of at some point in your life, is the following question. What's heavier, a ton of bricks or a ton of feathers? Now take a moment to think about this logically. What's heavier, a ton of bricks or a ton of feathers? Now, of course, to many people, as you probably well know, it's a bit of a trick question. The question is about mass or weight, and you're asked to compare two weights. A ton is a weight, and if you have a ton of feathers and a ton of bricks, then you have an equal weight of both. So they weigh the same amount. However, what if I asked you about the amount of feathers and the amount of bricks? Do we have the same amount? Well, no, obviously, of course not. We can clearly see we have far more feathers than we do bricks. Now, to put this into perspective mathematically, one feather weighs about 0.0082 grams. To put that into perspective, that would mean that 1 ton of feathers would be around 121,951,219 feathers. Not that I have done the math to check. Whereas with bricks, an average brick weighs about 2,270 grams, depending on the brick, depending on where you get it from, which means 1 ton of bricks is 440 grams. Now, this presents a particular problem. If I wanted equal amounts of bricks and equal amounts of feathers, do we mean the same number of bricks and feathers, or do we mean the same mass? Now, in terms of how this applies to chemistry, different atoms have different masses. So if we want to get the same amount of molecules or atoms of two different types of atoms or two different types of molecules, we can't really use the mass to do it, can we? Well, we can, but there's a little bit of maths involved. So to further explain this, just to kind of make sure that the concept has truly made sense, take, for example, carbon. Carbon has a mass of 12. Then let's compare that to hydrogen. Hydrogen has a mass of 1. If we were to have one single atom of carbon, we'd need 12 atoms of hydrogen to make up that same mass. So if I were to say to you, go and get me equal amounts of carbon and hydrogen, unless you ask me, do I mean number of atoms or do I mean the same mass, it can get very confusing. And this is a problem that we as chemists have. So because of that, we work with something called moles, or a mole. Now, to be specific about this, a mole is a particular number of atoms or molecules or ions, depending in which context you're using it. 1 mole is exactly 6.02 times 10 to the power of 23 atoms, or, again, molecules or ions, depending on which one you're working with. And this number is known as Avogadro's constant. Okay, great. Now we have a way of measuring a certain number of atoms. But here's the next problem. We can't count atoms. There is no such thing as a atomic tweezer or atomic sieve where we can simply measure out an atom or a molecule. So instead, we can do this mathematically. There is a formula in chemistry that you're going to become very, very familiar with. You will use this formula more times than any other formula you have ever learned. This I can promise. The formula goes as follows. Moles is equal to mass in grams times molar mass. Now, molar mass can mean atomic mass. So, for example, carbon weighs 12. Molecular mass, where, for example, H2O, 2 hydrogens, which weigh 1 each, and 1 oxygen, which weighs 16. So, water has a molecular mass of 18. It can apply to ions, molecules, or individual atoms. Okay, essentially, it's the same thing. Of course, if we're any good at algebra, we can also rearrange that equation. Now, if algebra is not your strong suit, it's definitely something you should work on for your chemistry, but for the meantime, we can use a formula triangle. The way a formula triangle works is you simply cover up the one that you want to work out, and it leaves you with the equation. So, for example, if we wanted to work out MR, we'd cover MR up, and that would leave us with mass over moles. If we wanted to work out mass, we'd cover mass up, and that would leave us with moles times MR. So let's try a quick example. How many atoms are in 0.1 moles of carbon? Well, if we know that 1 mole is equal to 6.02 times 10 to the power of 23, and we want to know how many atoms are in a certain number of moles, we can simply take that number of moles and multiply it by 6.02 times 10 to the power of 23, which in this case would give us 6.02 times 10 to the power of 22. This is a straightforward calculation. They can ask you how many atoms are in a certain number of moles in your exam, though it's not one of the most common questions. This, however, is something that you will need to be able to do very quickly on a fairly regular basis, and you will use in many other topics. So this is our first worked example. Carbon has an atomic mass of 12. How many moles are in 12 grams of carbon? So first thing we need to do is look at our equation. The question is asking us about moles, so let's cover up moles. If we cover up moles in the formula triangle, we can see it leaves us with mass over mR. So to work this out, we're going to divide mass in grams by the molecular weight. We have 12 grams, and the molecular weight of carbon, which we can get from the periodic table, is also 12, so 12 divided by 12 equals 1. Fairly straightforward. Worked example number 2. How many grams are in 2.5 moles of carbon? Now again, we know carbon has an MR of 12, and we can use our formula triangle again. The question is asking us about how many grams are in something. So this time cover mass up, and we can see we're left with moles next to MR, which means we multiply the number of moles by the molecular weight. Therefore, we have 2.5 moles, and the molecular weight is 12. Multiply them together, and we get 30 grams. And worked example number 3. This one is a little more complicated and a little bit more realistic in terms of what you should expect as an exam question, but again, this is quite simplified to start with. An unknown substance has been analysed, and it has been determined that it is an element. Analysis showed that the sample weighed 12.42 grams and contained 1.8 moles. Determine what the element is. Now, every element in the periodic table has a unique mass. No two elements share a mass, which means if we can determine the molecular mass of the sample, we can determine what element it is. So we're working out MR. To work out MR, looking at the formula triangle, we would do mass over moles. So to calculate MR, the mass in this case is 12.42 grams, and our number of moles is 1.8. We can construct that into an equation as shown on screen, and we find that 12.42 over 1.8 is equal to 6.9. Now, using a periodic table, we can find an element with a mass of 6.9, and of course we find that the sample is lithium. These are some fairly basic examples of what you would be expected to do, and generally speaking, it just takes a little bit of practice, but once you get your head around it, these are basically 3 marks in your exam. It's a really nice topic when you get your head around it, and also vitally important for future topics. This has been the Mole Part 1. Thank you for watching Van-Gelder Tutoring. If you would like to support the channel in a way that is free to you, please drop the channel a subscribe and like this video. Thanks again for watching, and stay tuned for Part 2.